Hi everyone, we are the Searchline team. I am Eleanor, Jiang. Today we are going to present on how we build a statistical model that predicts the percentage change in views on the YouTube video between the 2nd and 6th hours it's published. If we can successfully build the model, it will be helpful for the uploader to generate more revenues. We have a training dataset with predictors which generally fit into 4 categories: thumbnail, image, video, title, channel, and other binary variables. There are no missing values in the dataset, and we remove variables with zero variance and correlation higher than 0.9. We believe that published date will provide unique information, so we split them into 3 parts. They are published hours in a day, published minutes in an hour divided by in a 10-minute period, and published date in a week. Just by viewing the median lines, we can observe a clear difference in the response variable among different hours in a day. This pattern is reasonable because, for example, the video uploaded in 12 a.m. has a lower views increase in 2 to 6 hours. People most likely sleep in that time period. The minutes and day graph do not exhibit the same significant difference as the hours. Rather, we throw the hours and day into our predictor list, and the details of selection by bagging would be delivered by my teammate Xiong.
Hi guys, I'm Hongxiong and I will discuss our model part. To avoid overfitting and high computational costs due to so many predictors, we decided to run a bagging random forest to see the importance of all predictors. Let's see our importance plot. As we can see, those are 30 predictors with highest mean decrease accuracy, which means how much the accuracy of our model will decrease if we remove this variable. The number 30 is a decent balance between model complexity and error after our trials. We choose random forest model and train it with whole dataset for 2 reasons. Firstly, decision trees take their averages as final results with consistency. Secondly, our random forest achieves the lowest error among all our models. Then we choose OOB control for 2 reasons. The OOB stands for out of bag and applies the data for both model construction and error estimation, boosting model performance. Also, OOB saves our computational time with only 1 random forest constructed. As a result, our model explains 68% variance in the dataset. So let's deliver our next topic to Mengyu Zhang, who will talk more about our conclusion and further reflection.
Hi, this is Mengyu Zhang. I'm gonna to make a conclusion of our final model. Firstly, our final Kaggle score is 1.411 on public board and 1.416 on private board. The small difference shows the consistency of our final model, which means we successfully avoid the overfitting issue. Then we do have some cons. The model selection and feature selection are the main shortage since we are lacking of professional knowledge about social media development. Then we are using 30 predictors, which we believe can be reduced to a smaller number to reach a similar result. And in further research, we may perform some other variable transformation. For example, it is really hard to interpret the statistical meaning of the variable minutes by just dividing it into a factor with 6 levels. Also, after making an adjustment to the levels of variable hours, we do have a great improvement of our Kaggle scores. Also, we can change some parameters, such as mtry in random forest model. Lastly, we can apply some other variable selection method, such as lasso regression, subset selection, which we believe can help us perform a more accurate selection